Recording.
My slides in full screen mode, na?
Yeah.
1 minute. Someone join or ask permission. Okay, no one join. I have to give permission to students also, na? That's why I'm checking in between. Okay. Is it full screen mode? Hello?
Yes,
Yes,
yes.
it is.
Oh, yes. Okay, cancel. I'll present again. Okay. I hope it's full screen mode. So it's just you just confirm, Vijay. Hello.
Yes, it's full screen.
Okay. So good evening, everyone. My name is Deepak Kumar Patel. I'm PMR fellow at IIT Madras. I'm jointly working with Professor T. Pradeep and Professor Sundar Gopal Ghosh. This is my email ID. You can approach me for any query and any problem solution throughout this session. So since you have opted this NPTEL courses title as Structure, Stereochemistry and Reactivity of Organic Compound and Intermediate, a problem solving approach. A problem solving approach taught by Professor Amit Basak from IIT Kharagpur. And for this topic, you can follow this book, Jonathan Clayton. And for the basic of organic chemistry, you can follow this Paula Vibros, which I will recommend to you. So coming to the coming to the outline of this coursework, in first week we will discuss about the structure and stereochemistry. Starting from this, we will go through the asymmetric reaction of carbonyl. So before starting, I will just ask, give something like before, even in a research or a daily life, you should ask question like what, why, and how. This thing we should always question and answer ourselves. Like what is stereochemistry? Why stereochemistry is so important, and how we can use this concept in our day-to-day life and to solve the other problems. So we know our body are made of the proteins, and these proteins are made of the amino acids, and there are 21 amino acids in that. Only one this glycine. I will use later. Only one this glycine is a chiral, and rest are chiral. So the stereochemistry of the any molecules in the body play a very important role. So a detailed understanding of this is very important to learn. In 1950, one tragedy happened, like this thalamide tragedy. What happened like that time for the nausea or morning sickness in the pregnant women, the company have discovered one medicine, this. But that time they were not knowing whether this is the S configuration or R configuration. They simply distributed this medicine, and what happened in that time around 12,000 babies were affected with this. What happened like their hand or missing, only the palm and this joining like this you can see. So this was very tragic moment that time. What happened you can see like this is thalamide, this center, so the R enantiomeric and this is the S enantiomeric. So it's only changing the stereochemistry of this, how the drastic effect we can see in the medicinal chemistry. So understanding of this type of system is very important. That's why we will learn the stereochemistry of this. As sir have taught to you, I'm just briefly introducing the topic. Then we will discuss the assignment. I hope I'm audible and clear. We just confirm.
Yes, yes, sir, you are audible.
Okay, thank you.
Yes.
So the molecular point group they are assembled in a one tabular form, which is based on their symmetry operation. So the non-axial group, CN group, all the starting from C2 to CN, C8, like CN group, DN, D2N, CTN, B, like all the based on the symmetry operation, we can distribute in different group. And suppose you have a molecule. To start, just see the molecule, whether there are any axis present or not. You just follow this chart, you will get the exact idea of that molecules belongs which group, like whether it's the least symmetry group or the highest symmetry group or in middle. So this group will don't have any proper symmetry operation, and this group has the highest symmetry operation, and this in between. So you just follow this and identify your molecules. Your molecule belong to which group. These are the similar same thing like all the molecules possess the identity group, and this high symmetry order, rotation order will be the CN. Center of inversion one point where the all the equidistance point will be there. Like this, just these are the system of the symmetry operation. So one question is really what is the highest symmetry crystal system and lowest chemistry symmetric system. So the cubic lattice is the most symmetric of the any kind of lattice, and a triclinic is the lowest symmetry. So this was just a brief intro about the course topic which already you have learned in the last lecture from sir. So now I will discuss about the assignment. So coming to the first assignment, like the question number one is identify the point group to which the molecules A and B belongs. So this is the molecules A, this is molecules B. So molecules A, this E and A indicate the equatorial and axial point. This also similar. So the options are like A belongs to C1 and B belongs to Ci point group. Similarly, second option like A belongs to Ci and B belongs to C1 point group. They both belong these three. So there are some options. So to solve this question, you have to just first of all in stereochemistry, you have to be a very good imaginary person. You have to imagine the molecules in front of you. Just close your eyes, imagine this molecule. You will get every details of that molecule. So for that you have to draw the chair configuration like this. So, because in question they have indicated this is equatorial and this is axial, you can easily draw this. So this is the configuration, sorry, confirmation. Then this B. So what is happening? There is a point in between this ring which is equidistant to this and this. So this point have the center of inversion. Because of this, it is non-achiral, and this system don't have anything. So the answer is A got only a center of inversion because there is no any other symmetry operation. Obviously, C1 will be there in all the operation. Hence, it belong to Ci, and B is asymmetric molecules because there is no element of symmetry, so it belong to C1. So coming to the question number two, I'm not that fast, na? It's okay. You understand?
Yes, yes, sir.
Yeah. Okay. Ram, can you also give your output? You understand, na? Hello. He's there.
Probably he's not here.
Okay. So the question number two is consider the two reaction given below. So this is the some cyclization, ring closing reaction, this and this. So what is happening in reaction A and reaction B? This you have to track. Like question is identify the correct statement from the following option. A reaction A occur via 5 endo ring trig and B via 5 exodic. Both are favored. So for this type of question, you have to uh, see 1 minute. Someone is asking to join. Oh, Satyajit, you join. Okay. So full slide mode, na? Screen mode.
Yes, sir.
Okay. So for to solve this type of question, you have to remember Baldwin rule. We suggest like this how exo and endo play an important role for the ring closing of the sp3 hybridized carbon, sp2 and sp hybridized carbon. So the in question is like reaction A is a case of 5 exo ring. It is favored as a Baldwin rule, and B 5 indoor trig. What is it? Dig trig in my trig means tetrahedral. It's a sp3 hybridized carbon attached. So this and trig means sp2 hybridized carbon and dig means sp3 hybridized carbon. So this system is allowed for exo system. This for endo system. What is exo? What is endo? You have to understand. Suppose this is the electron rich system and this is electron deficient system. If electron cloud is going from the electron rich to electron deficient and the ring closing is happening. Like if the arrow is going outside, it's exo. If the ring is going inside, closing, it's endo. It's clear, na? Like just exo and endo. Exo means outside, endo means inside. So the first one will be the 5 exotic and second one will be the 5 endotic. These are the Baldwin rules, like which system will be allowed. Suppose you have to Tate. Tate means SS3 hybridized ring closure system. Indo, for 3 and 4 it's not applicable. 5, 6 not allowed. Only exo will allowed in all the case. 3 membered ring, 4 membered ring, 5 membered ring and 6 membered ring. For the Dick system means like sp2 hybridized ring closing. This is the electron rich going to this electron deficient. This electron again transferred to Y. So this is 3 membered, this is 4 membered, this is 5, this is 6, this is 7. So all the exo will allow, but Indo is not allow in this. Na? You can see like here this state. Na? This is coming like this. Is very too much strain in the system, so it's not favored. Similarly for trig Indo, 3 member not allowed, 4 member not allowed, 5 member not allowed. Only 6 member allowed in Indo. For exo means electron system flowing to outside, all the system is allowed. And for D, only Indo is allowed in all the case and exo, these 3, 4 not allowed, 5, 6 only allowed. I just give this to for your clarification. So question number 3 consider the three compounds A, B and C. Given below are the conformation equilibrium under the ambient temperature. So this is the question like one A configuration converting to the chiral, one converting to achiral, then achiral. Again the B like conformation one chiral. So all the conformation chiral in this. In this achiral. So whatever the conformation is happening, is someone asked to join or what? I have to check again and again. That's the problem. Huh. Uh, so question number 3, we are discussing about the question number 3. The this question how we can solve. The option A is like confirmation one, which is chiral converting to the chiral one. Then again is converting to the chiral. This compound B is converting to chiral, then chiral. So this will be chiral throughout the system, and this will become the achiral because one is achiral. And in this C system is converting from achiral to achiral, then again achiral. This all the system will be achiral, and this is also achiral. So to solve this type of question, you have to see whether your compound was chiral throughout the conversion or not. So only this B compound is chiral. So the answer of this like the answer is C. C like A, B, C, A, C, D all are achiral. Why? Because the achirality is there in the molecule. Only this molecule was chiral throughout the conversion. So coming to the question number 4, for the compound A and B, identify the correct statement. This is A, this is B. So like and by seeing this, you should always think there is no chiral center, they have the chiral plane or chiral axis. First, you have to differentiate. So this have the chiral axis uh, pointer plane. So this is a chiral axis which passing through this, and this is a chiral plane which pass through this. So to options are A has a plane chirality and its configuration is R. B has the axial chirality. First, to eliminate the options, you can see like A has a planar chirality. No, it's axial chirality. This is a planar chirality. So we can see in this like also to find the configuration of this, you can simply start naming from this side. Always this your ups and down should be away and this should be in. So this I am giving 1, this lone pair will be 2, this will be 3 and this will be 4. So how it's moved from 1 to 2 to 3 na? But fourth group is above. This is above. So it will be reverse of this. Okay na? Then it will be S configuration. Similarly, we can do this with this. You can see like the same thing I am saying here. When you are passing, that I show in different method. That but this concept you can apply. Always pass a plane through axis which is in the plane. Like you are passing through here. Arrow always draw arrow from this side to this side. This and start numbering from this. Whatever this will be 1, this will be 2. Then other side it will be 3 or 4. Any side. It's a very simple trick to solve this type of axial configuration we can do. And for this type of planarity, you can always look a point from you just view from this point and give the numbering 1, 2, and 3. If for this system you are getting the R configuration. Now coming to the question number 5, among the following compound A, B, C, and D, one of the highest symmetry number. So first, to solve this question, you have to understand what is this system. Like this is tetrahedral, and what type of symmetry operation is possible in this. And in this also, this is also like how many symmetry operation you can generate using this. That will be the from there you can see like for first one. Okay, 1 minute. Someone asking to join. Oh, left. Okay. So for the this question A, is have this have the point group T tetrahedral and all the symmetry operation in this is A will be present. Then four types of one C3, C2 like this C2 left. So total symmetry of operation will be 12. 3 from C2 and 4 from C3. One simple formula one is there like C3 plus NC2 is also. And for B compound D7H, D7H means all the symmetry operation will be there. So it will be the 4. Similarly for this tetrahedral, since this is the S having the S point group, it will have only E and C2. So the symmetry number of the plane will be the 2 only. For this system, this will be S6. So the E and C3 1 and C3 2. So the symmetry number in this is 3. So highest symmetry is present in this system number B. Coming to question number 6, which of the following reaction A, B, and C go via ketene intermediates? So ketene intermediates can formation you can if you even though if you are not knowing the reaction, you can think like where the ketene formation can happen. Just if you will resonate this negative charge will go there, this pi electron will resonate here and this here, and again it will go, then immediately N2 gas will be there. So this N2 gas formation is a driving force in this. ketene formation. So the A is a process via Wolff rearrangement, which involve the ketene intermediates. As I was explaining, this lone pair will delocalize for the N2 plus, and this again it will go. Then in presence of silver, then it will form the ketene. And the B is governed by the Hoffman bromide degradation, which form the isocyanide. So this only option A is correct. Coming to the question number 7, consider the reaction given below. This identify the correct statement from the following option. Whenever you are getting this type of chiral system and any aldehyde ketone group or any reactive species and having the metal center and some nucleophile, just you have to apply the Cramp's rule. You can solve this question. Like for this, you have to draw the like what is the configuration or configuration. Then this will chelate. This lithium is very much chelating toward the oxygen, so it will chelate to both oxygen, and it will adopt this configuration. Then Cramp's rule suggests like always nucleophile attack toward the from the less hindered side. So this is the less hindered side from the small group. So this configuration will form. So this is a major compound. So the correct option is D. You can read this like in the alpha carbon of the chiral ketone contain OH group which is capable of coordinating this. Lithium is always chelated with this type of system. So one to symmetric induction can be predicted using the Cram rule. Coming to the question number 8, which of the following study cannot be done on the basis of ORD and CD curve showing the cotton effect? So option A is the determination of the configuration of chiral molecule, position of the functional group like carbonyl, formation preference, configuration form preference, and this is a comparison of bond energy. So from the option itself, you can see like this option D is incorrect. Why? Because the comparison of bond energy can be we can't determine with this word. It's only the because it's a detect interact with the light only and give the conformational things, not a bond energy thing. For bond energy, you have to use the X-ray, like XPS instrument. So the option D is the correct of answer. Coming question 9, consider the reaction given below. This is the reaction. Some cyclization is happening. Identify the correct statement from the following option. A is the major product and is formed by 5 endo-D. For this, you have to remember as I explained in last question, Baldwin rule. I will go again here. You can see like that is the dig system because triple bond is there. So for dig system, which system is allowed? All the endo will be allowed. Only exo 5 member and 6 member allowed. No three and no 4 member. So from there you can solve this question. Uh, hmm. So what A forming 5 member, this forming 4 member. So 4 member, you can just see like this. What is happening? This form the iodinium cation. This iodinium cation again this from like similar kind of ring opening with NGP neighboring group participation. So there is two pathway to open. Like either this can attack via B pathway or A pathway. When attacking, when then it will attack towards A by A. It will form the 5 member ring. But when it will attack with B, it will form the 3 member. So so energetically favorable is like 5 endo-dig and 4 exo-dig. This will form the B, this will form the A. So the correct option is A. Coming to the last question, like consider the following statement. E and Z diastereomer are the reflectant variant. That is, E becomes Z and Z becomes E after mirror reflection. So identify the correct statement from the option. Option A is like can can never be true for any system. Be like always true for the system. So to solve these things, you can have the just you can have two cases where both sp2 stereogenic center. So this stereogenic center, what is the difference between stereogenic center and simple chiral center? Any idea? Anyone? Hello, hello. I'm audible.
Yes.
Okay. So I'm asking about stereogenic center and chiral center.
Stereogenic center is the center at which the new chiral center can be generated once the after carrying out some reaction.
You mean some distereotopic things? And like
Uh,
the
no, the presently the center is not a chiral,
hmm,
but if we substitute any group
hmm,
with other atom or
yeah.
a group which is already present in there, then it can be a chiral center.
So its name suggests stereogenic means this center is chiral due to the stereochemistry of this. And so in the case, what is happening here, like but when where both the sp2 stereogenic center are bonded to the enantiomorphic group, like this is RSSR. This is the E alkene and this is the E alkene. Mirror image is the E alkene. But in case of the only one of the sp2 stereogenic center is bonded to the enantiomorphic group. Like this is the R confirmation, this is S, and they don't have anything. So this is E, but what happened? Mirror, it will become the Z. So it is not always so that presence of the enantiomorphic group will make them reflection variant. However, it may. So I'm just reading. However, it may become reflection variant in a special case like case two. So option C was correct here. May be true for systems where the stereogenic carbon are bonded to an enantiomorphic substituent. So this was the question. Thank you. We will continue in next session. So someone joined late. I will just ask. One minute just. Hi Satyajit, you have any doubt, any question?
Hello, sir.
You have any doubt or question?
Mm, No, yeah, sir. First, uh,
You and like if you have any doubt and question, you can write to mail also. We can discuss. So you basically understand what we are learning in this like stereochemistry of this reaction and why it's important. So we will also help to solve the question. So today I only discuss 0 day from first assignment. No, sorry, first assignment I will discuss in next. I will combine both first and second to cover up because today no student joined, so I will ask to NPTEL team to whether I have to conduct like this. In next video I will next lecture I will discuss both assignment 1 and assignment 2. Vijay, you are saying anything? You are saying something, Vijay?
Yes, yes. Have you stopped recording?
Uh,
I mean, first week some question you can also cover this. Uh,
I'm thinking no student is here, so that's why
okay, okay, okay.
I will ask NPTEL team. So should
Mhm.
I continue recording like this? So it's fine, na? Session is almost half an hour only.
Uh, yeah,
Satyajit, like, hello, sorry, Satyajit.
Yes, sir. Yes, sir.
So you're trying to solve some question or not? Have you tried to solve some question?
No, sir.
No. Like how many lecture you attended in NPTL? It will help you to understand in very basic, So try to learn. It will help you to crack some competitive exam also because this is very important topic in any competition. If you are uh, giving some chemistry based exam.
Yes, sir.
So with this, I think I will. Vijay, you have any doubt, any suggestion?
No, I think no any suggestion.
Okay.
Yeah, recording is. I mean, how much time completed?
It's okay. That recording
Yeah,
will
that one. Okay, okay.
all the 10 question I covered, and next session I will cover both assign. I will try to manage both assignment because today I just wanted to interact with the student, but no one joined. Only one Satyajit joined.
Hello, sir.
That yes, yes.
Uh, so, some topic I don't know how
Which
to cover this topic.
which
This
topic?
topic
Like
as something
history chemistry related or some other chemistry topic?
stereochemistry related.
Okay. So you just see the video NPTEL lecture, which already professor. You will get some mail, I think. You got all the lecture. How many lecture you got? Like how many
This is
lecture?
my first lecture.
This is a question answer session, not a assignment discussion. Am I correct, Vijay?
Correct.
You have to see the lecture from the NPTEL course. There are lectures are there in which
Hmm.
Professor Amit have taught you.
Oh, oh.
From there you learn from their lecture. Then for the problem solving, you can discuss with us what type of problem you are having. Like your NET, GATE or IIT JAM, if you are preparing those type of question, you can also discuss. No problem. We will help.
Satyajit, can I, uh,
Yes, sir.
Deepak, can I share screen so I can show the Satyajit so where to access these lectures?
Okay, yeah, yeah.
Or otherwise you can also do that.
You just do na. Okay.
Uh, yes. So uh, is my screen visible, Satyajit? Uh, So hello, Satyajit. So when you go to the course after login,
Okay.
you can see here. I mean, my courses, right?
Okay, sir.
Uh,
Yes.
then my courses, whichever courses you are enrolled for, here you just need to go to course, and here you can see their first week sessions are there already. This uploaded. These are the videos. So you need to click on that one, and you will get your entire lecture here. It's almost 40-minute lecture. See all the topics. So you first need to see this video, all the video. Here is the third video. All topic wise videos they have given for first week, and since it's second week also started, so here you can see the second week videos as well.
So we will suggest you to please watch this video and
Huh.
for the
So,
solving this
right, right.
question.
And if you face any problem, then just share with us. We can solve this one. So these are the videos already uploaded on the portal. You need to log in there, and you can see here all these lectures uploaded there. So since these are the second week videos are also uploaded, and you just need to open here like this, and you can see professor
Okay. Okay.
already teaches. here. I'll just stop sharing.
Satyajit, you got na?
I, yes, sir.
You got na? You got point. Vijay point.
Yes, sir. I
Uh,
got.
you just follow those lecture and try to solve the problem. Whatever the given in that assignment, we will help you to solve that assignment also. We will discuss with you what's problem we are facing to solve them. We'll discuss with that.
Okay, next time.
And yeah, like I will conduct every Sunday this time, and Vijay will conduct whatever the time he has given to you that time.
Okay, sir.
Okay. So with this, Vijay and Satyajit, I am closing the meeting. This discussion.
Thank you, sir.
See you in next session.
Thank you very much, sir.
Welcome.
Thank you, sir.
Welcome.